This study looks at electronic gaming, motivation, and the acquisition of mathematical concepts and fluency in third grade students. Hello everyone, my name is Teresa Kojo Julian, and I am in the Education Specialist Degree Program in Instructional Technology at Kennesaw State University. I am a fourth grade teacher working at one of the local elementary schools here in Atlanta, Georgia. After reviewing the 2012-2013 CRCT math scores for third grade and the school, it is obvious that improvement is needed. The third grade students of the local elementary school meet and exceed state standards on the CRCT, Criterion Reference Competency Test, by 49%. 41% of the third graders do not meet state standards. Once students develop a solid understanding for what I call the basic four, addition, subtraction, multiplication, and division, they gain the foundation to apply these skills to other mathematical concepts. The basic four is implemented in every mathematical concept, such as measurement, geometry, fractions, problem solving, and algebra. A lack of these computational skills will almost guarantee mathematical difficulties in the short and long-term future. In some extreme cases, a lack of basic four understanding can bring mathematical acquisition to a devastating halt. Students develop high levels of motivation and learn best when concepts are presented through experiences. Electronic games can be a motivating factor to encourage basic four acquisition. Gaming can provide active experiences through manipulation, graphics, animation, and song that may not be provided when using traditional learning. In mathematics education, the need to develop math fluency is essential to the acquisition of all math concepts in every grade level. The purpose of this action research study is to explore the effects of electronic gaming on motivation to acquire mathematical concepts for third grade students. Understanding the basic four can solidify successful development of mathematic fluency. Electronic gaming seems to motivate students to learn math skills and perform better on state assessments than students who participate in traditional learning. Fing 2013 and Cabrici 2008. Some studies suggest that competitive play produces students with higher math skills acquisition than individual play. Class 2013. Students engaged in handheld gaming show a significant increase in speed and accuracy in math fluency, as well as good self-concepts in math. Main et al. 2011. In the classroom, students may not be willing to put the effort into learning math concepts, but are motivated to learn them when engaged in electronic games. Gillespie, 2012. In the study by Ray et al. 2012, pre-service teachers indicate mixed feelings when questioned about the use of electronic games in the classroom. They feel a fear of being pushed aside and loss of control when integrating technology in such a student-centered way. The participants are 6 third graders with low grade point averages. They also participate in the after-school tutorial program for math improvement. The students are boys and girls, African or Latino American, who speak either English or both English and Spanish. Attitude assessment questionnaires are used to assess the attitudes of students toward learning mathematics and the use of electronic gaming in the mathematics classroom. Other professionals in math collaborate with me to analyze and interpret the findings. I conducted a pre-test of math fluency using the Georgia RESA Assessment of Student Progress, GRASP. Then, students engaged on academics.com, an electronic gaming website, and worked on the basic four: addition, subtraction, multiplication, and division to improve concept skills. After 2 weeks, students took the post-test of math fluency, GRASP test. Attitude assessment questionnaires are given for the second time after the electronic gaming experience. This time, it is given to assess the difference in the attitudes of students from the beginning to the end of the study. How have student attitudes changed toward learning mathematics and the use of electronic gaming in the mathematics classroom? Does electronic gaming increase or decrease motivation to learn the basic four? Data collected from the pre and post math fluency test is analyzed by a t-test, paired to sample for mean score. To represent the change of math fluency acquisition from the beginning of the study, before introducing electronic games, until the end, after electronic game introduction. The findings show that math fluency seems to increase after playing electronic games, mean equals 4.5, than before electronic games, means equals 3. Were the results due to the treatment, the electronic gaming experience, or chance? The t observed equals negative 1.2, and the critical t equals 2.01. P-value equals 0.12. Because p-value is greater than 0.05, the results may have occurred due to chance. The null hypothesis is not rejected. A paired t-test shows that the difference between mean scores is small, which indicates that the treatment, electronic games, may not have been effective. Here is the math fluency rate of each student for the GRASP pre and post test, represented in percentages. Here is the math fluency rate of each student for the GRASP pre and post test, represented as a bar graph. The data is analyzed by a Likert scale questionnaire at the beginning and end of the study to measure the attitudes and feelings of students on mathematics and electronic gaming. The data is analyzed by a Likert scale questionnaire at the beginning and end of the study to measure the attitudes and feelings of students on mathematics and electronic games. Overall, students enjoy learning mathematics despite their low grade point averages. Introducing electronic gaming into the study eliminated negative feelings about math for some students. Enjoyment of playing electronic games increased. Students wanted more time working with the computer in class and less time listening to teacher talk. In the beginning of the study, 66% of students felt that electronic games should not be played in class. After the study, 100% of students felt that electronic games in the class was a fun way to work on what they had learned. The findings support the use of electronic games to motivate the learning acquisition of the basic four. However, keep in mind that support is limited. All instructional strategies designed modeled, facilitated, and implemented are based on research. All aspects of education are driven by research-based data, and educators are involved in data collection every day. Having an understanding for the process and the product of research promotes better instructional practices and improves student learning.